Okay, hi guys. Today we are looking at index law number one. So index law one. Now there's a whole bunch of these that you're going to have to write down over time. And this first one is a multiplication law. It is based around multiplying. So I'm just trying to get that in focus. Multiplying two numbers together that are indices. So multiplying, 2 squared and 2 to the power of 3, something like that. Right. So the law looks like this. It's a to the power of m times a to the power of n. Right. I might just make that a little bit closer, just so you can see it a bit better. If it'll focus, that would be terrific. Okay, there we go. Yeah, alright. So a to the power of m times a to the power of n. That equals a to the power of m plus n. Now that's the law, and the law's in algebra, and I understand that some of you look at that and just go, this is gibberish to me. So what I will do is I'll just do a couple of examples and show you what we're doing. So let's say we had 2 to the power of 3 times 2 to the power of 5, right? Now, stay in focus. So 2 to the power of 3 times 2 to the power of 5, that's what we got. Now, the law states that if the base is the same in both numbers, which in this case it is both 2, our answer is also 2, or has a base of 2 also, right? And then we plus the two powers together, like we did m plus n. We do 3 plus 5. So what's 3 plus 5? Well, that would equal 2 to the power of 8. And that might be a little bit confusing if you're not too sure how that's going to work. So what I will do is I'll break these numbers down into their extended forms, and then that way you can see that the way that this works is, like it checks out the way that this works. So 2 to the power of 3 is 2 times 2 times 2. Multiply that by 2 to the power of 5, which is 2 times 2 times 2 times 2 times 2. Right? Now if I'm simplifying all these 2's being multiplied together, I get 2 to the power of 1, 2, 3, 4, 5, 6, 7, 8. 2 to the power of 8, right? So if my camera ever focuses, you'll see that that rule checks out. Right? So that makes sense. That's the general, I guess the general rule for you. They can be a little bit harder, so I'll do one a little bit harder just in case you want to see what that looks like. If you had something like, let's say you have a to the power of 6b times a to the power of 2, say b to the power of 3, and c, right? So this is a more challenging one. I've got a whole bunch of things together, right? So I've got a to the power of 6b, and I've also got a to the power of 2, b to the power of 3, and c, right? So this is one of the harder ones. So following the rule, I would just plus, if the base is the same, I plus the numbers together. So for a, I do 6 from here, plus 2 from here. Right, so my A's are all done. I have B and B. So if B has no, One thing that I should point out is if a letter has no index next to it, that's the same as being to the power of 1. Right? So B is 1 plus 3. Right? And then C, well, there's only one C. So that's it. Alright? So that would be A to the power of 8, B to the power of 4, C. And we check out and see if this works by going 8. I'll write this out in its extended form. So there's 6 A's, 1 B, 3 more A's, 2 B's. Oh, so it's 3 B's, and then a C. Right? And then all I'm doing is I'm just counting up how many of each of them are, and hopefully it matches what we've got here. So for A's, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, did I count that wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9. Ah, I've written that as 2. That's why. Whoops, I made a mistake there. So that should be 8 to the power of 9. Okay, so 8 to the power of 9. How many B's? There are 4 B's. How many C's? There's only 1 C. So that's my answer. Alright. So that's a more complicated one. That's probably the more straightforward answer. So if you want to use the index law, just plus the powers together and keep the base the same. If you're struggling with that, just write it out in its extended form and work it out that way. And that's where we're at. So you can jump on and do some work to do with this. All right, take it easy.